Michael. Hey, Michael.
Yeah.
Yeah, so if it was 3a times 12.
I'm going to teach that.
No, it's 30.
Because I can tell you what it is. I know, but I don't want you to memorize. The answer is 36A. But I don't want you to memorize it. I want to teach you why. Okay, so don't memorize.
Hey, Michael.
All right, here we go. Shh. Quiet down. Exercise looks open. Yes, Lizzie? Well, you can memorize. Yes, you can, but you have to understand why. So if you don't understand why, that's where it gets. Yeah, it's when you do something wrong. So it is. Yes, it's true. You memorize stuff like your times tables. You memorize that, but you have to understand what times tables is. Otherwise, when you start doing year 8, year 9 algebra, then the reason why you keep forgetting it or you're getting it wrong is because you don't get it. You think you get it, but you don't. Okay?
But you
So
have to memorize why.
you have to understand why, and then you can memorize the technique.
You have to memorize the understanding.
By practicing.
You have to memorize the times means.
This is all being recorded, Elliot.
So it's all. So it's memorizing. So you're memorizing before you memorize. So you're memorizing the understanding. So you don't have to. So you understand the memorization.
Yeah.
He's doing the video.
No, you did that absolutely correct. It was understand your memorization.
What did you just say?
All right, here we go. Let's go with collecting like terms. This is exercise 5D. Now, collecting means you're going to gather. Like terms, you already know what a term is. So we're going to start off with how many terms do I have in 3x squared plus 4y plus 7a plus 6 minus 2x. How many terms do I have? Yes, Kiwi?
5.
How many? 5. So I have what, Kai?
3x, 4y, 7a, 6, and 2x.
Very good. You said 3x, but it's 3x squared. So that's one term. Yeah, 4y, that's correct. 7a, that's also correct. 6, and then you got the minus 2x as well. So that is 5 terms, but you were going to say? Were you going to say something else?
Yeah, so 3x.
Okay, fantastic. So you got 3x squared, 4y. These are your 5 terms. Now, when we say collecting, that means we're going to gather. Now, these are the terms, but what we need to understand is what does it mean by like terms? What does it mean when we say like terms? So, Lizzie.
Would it be like the 2 x's? Because like that's the only similarity I can see.
Yep, and that's where I wanted to pinpoint today. Technically, all of these terms are different. And a lot of the time students get this wrong, especially in year 8, when you start doing multiplying, adding, dividing, there are some rules that you'll start to mix up. And the common one that you'll mix up with is the x squared and the x. Those 2 terms there, a lot of students will mix this up because they see, oh, they both have an x, therefore I can collect them, and what they'll write is 3 minus the 2 is 1, and then they'll say, what do I do with the x squared and the x? Now, once you learn how to multiply and divide, they'll make up some rules here. Okay, so the next common rule is they'll write x cubed. And you'll find out why when I do 5e, you can see why students normally make that mistake. That's why I emphasize a lot about understanding what the x represents so that you don't make that mistake. Okay, so to answer your question, no. All these terms here are different. This is an x squared term. Okay, you got 3 of these x squared terms. This is a y term. I have 4 of these y terms. I have a's, and there's 7 of these a's, and I've got just a 6. Whereas over here, I've got minus 2 of these x's. This x is different to an x squared. It's kind of like saying students are different to teachers. Yeah, but we're all humans, so we're all x's, but there's a difference between my role and your role. Okay, so we've got about 20 odd students in this class, so you guys are a collective term. But if I asked how many teachers there are in this room, you wouldn't say there's 21 of us, you would say there's only 1 teacher. Yeah, so it's the same thing here. X squared, though they might share the same variable, but it is a different term because you've got a square. Does that make sense? Yeah? Yes, Daniel? Oh, sorry. I didn't mark it as well here. I forgot to mark it.
Wait, how come you forgot to mark so many?
Yes, oh no, I just did the whole box. I left it at school yesterday when I went to the VC Expo. Alright, here we go. So, let's go with what a non-like term would look like. So, This is an example of a non-like term. So you can't collect these two. That means you can't say 3 plus the 5 because you know it's not the same groups. It's like saying Y is your apples and Z are your bananas. Then you'd say I've got 3 apples, 5 bananas. You don't say I've got 8 apple bananas. That doesn't make sense. You can say you got 8 fruits, but that's a different category. Yeah, in this case here, if Y represented your apples, then you got 3 apples, and if Z represented your bananas, then you say 5 bananas. But you can't group them together and say, yes, I now have 8 apples and bananas. Okay, that doesn't make sense. You only got 3 apples, 5 bananas. Whereas, if I wanted to be like terms, this is a like term. You see, this is saying I've got 3 groups of A, and A could be anything. It could be apples again. Then 5A, so I've got another 5 groups of A, so I've got another 5 apples. Now you can say, together, 3 apples plus another 5 apples gives me a total of 8 apples. And it makes sense because when we say 3A, what does this mean again?
3 times A.
3 times A. But when you say 3 times A, what does that actually really mean? Yes, because you're saying you got 3 groups of A, so this is A plus A plus A. True? And then if I say 5A, what does that mean? 5 times A, which actually means what?
A plus A plus A.
A plus A plus A plus A. So what I'm really saying in this line here, plus A, what I'm really trying to say in this line here, if you think about 3A plus 5A, if you actually really break it all apart, it actually just means A plus A plus A, that's 3A. And then I say add on, I add on. 5A, which is A plus A plus A plus A plus A. Can you see what I'm doing there? I'm just writing out what I see. And this makes sense when you collect them. Well, think about it. Instead of writing A plus 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 A, why don't you just simplify it and say that's just 8 groups of A's. That's why you can say here that this is equivalent to 8 groups of A, which is 8A. And this is what the exercise today is, that you're only able to collect items because they have the same category. Whereas if I had A squares and A's are different. Okay, you can't just group them. Same thing with this one. This would be Y plus Y plus Y, and then this is plus Z plus Z plus Z. Well, another 2 Z's. Yeah? And you can't collect that. You can't say I've got 8 YZs because it doesn't make sense. Okay, so that's what I meant by understanding. When you're doing the algebra, what it means to say why we collect the terms. And we can only collect them because essentially they're the same thing. Okay? Essentially they're both the same group. So you can say A plus A plus A, plus A plus A plus A plus A, but that's much easier just to say I've got 8 of these A's. How's that feel? Difference between non-like terms and like terms. Is that easy? Alright, let's try an example now, okay? Let's try, the be careful, Lizzie picked it up before already, so I'm just going to ignore it. It was be careful of, just because you have the same letters, doesn't mean you can collect them. So A squared and A, and it was the same thing with X squared and X, they're different terms. Okay, so most students would think this would be 8A, and then they get confused here. And once you learn 5E, you're going to mix those two rules together, and you're likely to say it's 8A cubed, which is not true. Okay, and I'll show you 5E when we get there, yeah? But here we go. So, let's identify which ones are like terms. So let's say A. Is A like term? I've got 3x and 2x. Are these like terms? Yes, they are. So these are like terms? Yes, they are. What about 3A and 3B, David?
No.
No, these are not like terms. What about 2AB and 5BA? Yes, they are.
What?
Okay.
They're the same thing or they're different?
The other way around.
Yes. See, this is all about the understanding. We break it apart. 2AB, what does 2AB mean again?
2 times A times B.
2 times A times B, because when you write a letter next to each other, it just means times. We're just lazy to put in the times symbol. So this means 2 times A times B. Now, if you write this one, this is the same thing as writing 5 times B times A. But if you think about it, multiplication, it doesn't matter if you do 2 times 3 or 3 times 2. It doesn't matter about the order. Yeah, 2 times 3 is 6, and 3 times 2 is still 6. So when you say B times A or A times B, it should still be the same. Technically, I can rearrange this and still say it's 5 times A times B. The answer shouldn't be different. So another way of thinking about it is if I said 3 times 2 times 1, it doesn't matter if I switch the 1 and 2. True? 3 times 2 times 1 is, but then if I switched out 1 and 2, 3 times 1 times 2, still 6. So it's the same thing with 5 times b times a is the same thing as saying 5 times a times b. So that means these two have 1a, 1b. This has 1a, 1b. These are the same terms. See what I'm doing there? So another way of thinking about it is when you say 2 groups of AB, that means I've got AB and another group of AB. That's 2 groups. Whereas over here, you're saying you've got 5 groups of AB, which just basically means AB plus AB plus AB plus AB plus AB. So if you put them all together, they are like terms.
Can't A, B, or 2 letters sometimes mean one number? Because otherwise there'd be only 26 possible numbers.
Perfect. Yes, AB could be, and that's where the calculator, this is more of a calculator thing. It depends on how you write it. Most of the time, if you're using a different letter, it means it's a different number. But unless it's specified that they say AB is a number, which normally in our questions, they don't say that. Normally we use different letters for different numbers. Yeah. So in your calculator though, or later in year 10 and 11, they can't tell the difference. They can't tell, you have to tell them. So they'll automatically assume if you type AB, they're like, oh, they must be together. And that's just one number. So AB is one number. For us, we know. We know that A is a letter and B is another letter, and those two are different numbers, hence B and A. But a calculator will see it as one, because you can type words into the calculator later on. You can type things like factor, and it won't separate F-A-C-T-O-R. It will only see it as one word. And that's just part of the programming. So in order to make sure that the calculator doesn't know...
It just has a little thing of letters on the side, and you just have to teach.
Yeah, but yes, so in our case, we know that AB is actually 2 numbers multiplied to each other. The calculator won't be able to tell, so that's why you have to put a time symbol in between. Okay, but there you go. So we now know C are like terms because B, A. You kind of look at the letters and you say, well, I've got only one A, I've only got one B. Are they both the same powers? Yes, they are. There's only one A, one B. Doesn't have A squared, doesn't have B squared. Okay, so those are like terms. What about 4K and K for D?
Yes.
Like terms, fantastic. Yes, they are. What about 2A and 4AB? No, because if you break this apart, you've got 2 times A. This is 2 groups of A, whereas this is 4 groups of AB. See, this one has a B, this doesn't have a B. So these are different groups. They both have the letter A, true, but that's an A with a group B together. Okay? Is that no, that's not a question. And then lastly, 7AB and 9ABA. No. Okay, those aren't like terms. Are we starting to pick up what's like terms and not like terms? Yeah. Yeah? All right. Now, I want you to simplify. I'm going to do the first 2, and then you're going to start to slowly simplify, okay? So I'll do the first one, A. We have 7B plus 2 plus 3B. Now, in order to collect like terms, it means you collect things that are the same. So like teachers and students, remember that. So how many teachers are in this room? There's only 1. But if I were to collect the number of students, so there's 2 on this table, there's 3 on this table, so together on this table, I've got 2 plus a 3 number of students. It's 5 students, 1 teacher. Now, if you look at this, what are my 2 like terms up here? Can I please have, let's go, yes, Aina.
7B and 3B.
7B and 3B. So these 2 are like terms, which I'll highlight. 7B and 3B are like terms. So that means I can group these together. Instead of writing 7B plus another 3B, why don't I just collect them together? Now, if I've got 7 groups of B, and I'm adding another 3 groups of B, in total, how many groups of B do I have? 10. Okay, 7 plus 3 will tell me it's 10. So now I can say, well, that just gives me 10B. Whoops, not that one. Here we go. We now have 10B, but I still have that add 2. Now, most students, when they're first learning collecting like terms, they may add these 2 numbers together and say it's 12B. But why is that wrong? Yeah, so they're not like terms. Okay, I know it's just a number, but that's a term. That's a constant term. This is a term, but it's a B term. And I've got 10 groups of these B's. If you actually break it apart, it actually just means B plus B plus B plus B. Oh my God, this is going to take a while.
B times 10.
How many B's have I got already? 4, 5, 6, 7, 8, 9, 10. And then that's technically what you're saying in that line there. Okay, and it makes sense that you can't say, I've got 12 B's, because I don't. I only got 10 B's with an extra 2. Okay, and those two are different. You can't just say the answer must be 12B because it doesn't make sense. I don't have an extra 2 B's.
So for question for 5 Ds, for that question 5, and whether you just made the answer as 10 and then
Perfect. That's it. That's all you leave. Your answer, finally, this is as simplified as you can go. 10B plus 2. Okay, that's the answer you want to leave it as. That's simplified because it's better than writing 7B with an extra 3B on the side. You can just write it as 10B. Lizzie?
If B equal 1, then it will equal 10, but if B equal 1,
And that's very good. So what you just said was you made a variable there. You made B the variable. You said if B was 1, yes, it does equal to 12. But then if B equals 2, then it's 10 groups of 2, which makes it 22. And because we don't know what B is, we'll leave that as a variable. We call it 10 times B. But we know that 2 is a constant because it always stays as 2. It doesn't change. Constant means it stays the same. 2 is always going to be the same. Yeah? Let's try B. What about B? I've got 12D minus 4D plus D. What are my like terms here? Can I please have, let's go with Caleb. What are my like terms?
4D,
Yep.
D.
And D, yeah. They're all like terms. They all have a term D. That has a D, that has a D, that has a D. Now I've got 12 groups of these, I've got 4 groups of these, and I've got 1 group of D. But what I'm really saying here is I'm saying 12, take away the 4. Okay, because I'm losing 4. I said I've got 12 groups, I'm losing 4 of these groups, but then I'm adding another group. So how many in total I have? 9. 12 take away 4, which is 8. So I've got 8 of these D's, but then I go, all right, 8D plus D, that gives me a total of 9 D's. Okay. All right, that was B. Let's do E, just to see.
That was D.
Sorry, that was B.
D.
That was B.
That was B?
Yeah, I just did B.
Oh, right. No, I thought you were talking about exercise B.
Oh, no, that's exercise B. Yes, 5D. Let's finish off the last one. You do it. I'm going to pick someone right now. Let's go. I want you to have a look, and then someone will explain to me. So, what is your answer for example E? Can I please have... Yes, Lizzie.
12 plus 3, and that's 15, and then 7 plus 3. Yeah. Wait, what?
Oh, you were close. You said 12, but you said plus. It's not a plus right now. What is that? Minus. So 12 minus 3?
7 plus 3.
And 7 plus 3, because these are V's. So those go together. So you got 10 V, and what's 12 take away 3? 9. So we've got 9 groups of these UVs, and then you've got 7V plus 3V gives you a total of 10V. So they might both have a V, but they're both different groups. So 12 UVs will go with 3 VUs or UVs. Okay,
Sounds like you're talking about, the UV that
yeah, I know. It does feel like that. It
It
gets...
sounds like before it sounded like you were talking about bees, and now it sounds like you're talking about
Too many B's and V's.
ultraviolet. Ultraviolet.
All right, I'm going to highlight what are the like terms. So UV and minus 3VU, because VU and UV are the same thing. Okay. Minus 3VU, which is the same thing as saying minus 3UV.
It's like you versus someone.
UV light.
UV light, that's what I was thinking.
That was like.
All right. How do we feel with that? That's exercise
D.
D. Those two together.
Is there music behind it?
Is there?
Music behind
I hope not.
I hope so.
I hope not.
Bye, Michael.
No, we got to go to 7E. I mean 5E. 5E.
Michael's gonna watch this.
Okay, so.
Putting this on the YouTube.
Yes, I am.
Call it Michael's video. Call
Now
it Michael's video.
that you know, like and subscribe at the end of this video. So now we know how to collect like terms. That was for adding, subtracting. What we haven't done so far is multiplying, dividing, and this is where students will get these two mixed up. You can add, subtract, and as soon as I teach you how to multiply and divide, there's going to be a mix here. Okay? So that's why I want you to understand it so you avoid making that mix. And it always happens. Okay? It always happens. You mix it up. It's kind of like fractions. When you learn how to add, subtract, you guys were fine. Then I taught you multiply and divide to simplify, and then suddenly you guys mixed that up. So when it came to time, sometimes you made the denominators the same, but you didn't have to. That was only for adding and subtracting. Yeah, same thing with this one. When we're collecting, you only need to make sure it's the same A's and B's, but now when you're multiplying, you'll find that you don't even need that anymore. Okay, so let's have a look. We're going to do multiplying expressions. We're learning to multiply first before I go to divide. Multiplying. Let's have a look at what does 3a mean again. Good. So this is a... Oh my god. Why is it always coming up with a highlighter? Here we go. We've got a plus a plus a, which also means 3 groups of a. Okay, so 3 times a. Then if I gave you this one, 3ab, what does this mean? Good, this means 3 times a and also times b. Another way of thinking about it is you could say it's the same thing as saying 3 groups of ab, which another way of saying 3 groups of ab, which is? Good, ab plus ab plus ab. See how I've got 3 groups of those? Okay, so in this case here, yep.
Remember how you said before it could be just, they could be 2 different numbers?
Yes.
And
these
that's
are
one number, so that could be like 26 something. It's 26 plus 26 plus 26 times 3.
yes. No.
Well, it's
No.
not
I think I understand what you're trying to say. If let's say hypothetically a was equal to 1 and b was equal to 2, hypothetically, right? You could still say 3 times 1 times 2. Okay, so up here this would now become 3 times 1 times 2. Agreed?
Yeah.
What does that become? 6. Okay, let's try the second one. This is 3 times, now AB still means A times B. Now what's 1 times 2? 2. So instead of writing 3 times 1 times 2, I can still write it as 3 times 2. What is that equal to? 6. Still the same. And if I go with the next one, AB plus AB plus AB, well what's A times B? 2. So this is the same thing as saying 2 plus 2 plus 2, which is still 6. But all the expressions are all the same. Yeah? Okay? Yeah. And that's what I mean, like try to understand the letters as a number. A number. Okay, you figure it out as a number, then when you start doing, these are the ones I'll show you later, and you'll see why most students get this mixed up. Okay, so let's try this last one. So this is the one where students will freeze up, and if I tell you the technique, you'll figure it out, but there's a difference between understanding it and memorizing it. Yeah? The answer to this, most students will pick up the strategy is numbers with numbers, letters with letters. That's how it's normally taught. I don't like it that way. Yeah? Most students will do 3 times 5, 15, and they write 15AB. It is correct, but that's where they get the whole mix up. So let's think about this. You could do 3A, you could do 3AB. What have I done here that made it different? I separated variables. One more thing there. What did I do? I added a new number. That was the key thing. Because if I didn't have that 5, technically that is still the same as this. True? Because that just means 3 times A times B. Agree? So all I've done is I put a 5 into it. Now, it looks visually different, but let's think about this. What does 3A mean again? 3 times A. So this means 3 times A. Now, I still have a time symbol here, so that's times. What's 5B? 5 times B. Now, if you think about it, when you're multiplying, it doesn't matter about the order. True? You could do 3 times 2 times 1 or 3 times 1 times 2. So the reason why students look at this and go, oh, no, that looks scary. What if I rearrange it? See, if I rearrange this, if I rearrange these two, this now becomes 3 times 5 times A times B. Does that feel a bit easier? Yes. And it's just about the order and how you see things. You see, when I switch the A and B's, because it doesn't matter whether you do A times 5 or 5 times A, it's still the same. Right now, you can see that I might not know what 3 times A is, but I do know what 3 groups of 5 is. 15. And that really just means I've got 15 groups of AB. That's the logic. Now, just in case that still felt a bit confusing, another way of thinking about this is you can say I've got 3 groups of A5B. True? Because all I've done is right here I've got 3a, 3 times a, so 3 times a, and that just means times. So instead of writing in times, I'm lazy. I'm doing a times 5 times b. True? Now if you write it like this just means I've got 3 groups of a5b. Now 3 groups of a5b will look like this. It will just be a5b plus a5b plus a5b.
Which would be A,
Yeah, because you got 5 plus 5 plus 5. That gives you 15 of these A, B, A, B. True? If I rearrange that, if you didn't like the look of that, I could write it as 5AB plus 5AB plus 5AB. And you would tell me that is 15 AB.
I think the first one is easier.
Yeah, it is. But what I'm trying to do is I'm showing you multiple ways of seeing it. There's never one way for mathematics. Mathematics is meant to be the logic of breaking it all apart and grouping it. That's all you're doing. I've just broken it up in a different way so you can see when you say 3 times A times 5 times B, you could see there's 3 groups of this. Or you can actually just see it as they're all times to each other, and you can say, yeah, I know what 3 groups of 5 is. That's 15. 15 groups of AB. Same thing. Okay?
You know how you try and match the variables to the variables in there? What if the variables equal to a number? It doesn't matter. Like, you know, for example, at this moment we don't know what they are. It could be, you know, any number.
Yep.
But what if they're like? What if it's 15? So technically, it could, instead of matching it could just be, you know, 3 times A, which equals to 15. You know,
it could. And that would then be called evaluating. So in our case, the technique that what we're doing right now is called simplifying. We're simplifying, instead of writing 2 terms, we simplified it down to 1 term. But what, you're right, what if we did know what A or B was, then what you're doing now is you're evaluating, because you're finding out what the value is. You're evaluating it. Okay, so it's dependent on the question. If they want you to evaluate or not, they'll tell you what A or B is. Okay, but if they don't, your goal is just to simplify. Okay. Now, once you understand that, this is where the confusion comes, and I'll show you why most students. So most students will pick up on this and they'll say, oh yeah, 3 times 5, 15, 15 AB. But this is where it comes. What if I gave you this one? Let's start with this. 3 squared. What does 3 squared mean again? 3 times 3, not 3 times 2, yeah? This is 3 times 3, which gives us what? 9. Okay. What if I change it to this now? 4 times 4 times 4. What's another way of writing that? 4 to the? Good. This is now 4 to the power 3. Anyone happen to know what it is?
4 times 4, 16. 16 times 64.
64. Good. Okay. Now, if you can do numbers, you should be able to do letters as well. They're the same things. Letters are numbers. They just look different. Okay. So you got 3 squared. You knew it was 3 times 3.
so like A, B, C, D equals 1 plus 1 plus 1 or something.
No, not yet. You're close though. What if I gave you that now? Good. Very good. This is A to the power 3. And in year 8, year 9, I keep fixing this sort of concept. Most students will confuse between A cubed and 3A. I will always get that. There'll always be, I can always grab a test right now from the year 9s. I can promise you there will be a mixture of this. They'll get these two confused because time is different to add. See, 3 times A has the time symbol as well. And that's why a lot of students think, oh yeah, A times A times A, and they'll write 3A. But it's not. Because remember, when you say 3A, it actually means?
A plus A.
It's 3 groups of A's. So this actually means A plus A plus A, whereas A times A times A is A cubed. But you don't mix it up when I do it this way, because they're numbers, you're familiar with them. But when it comes to letters, these are the two that normally mix. This is where it comes up as well. So if I show you an example of, actually I'll do it over here. So if I gave you this question, you were able to do this before. You did 3A times 5B, true? Now what if I change the B, if it rubs off of course, well it doesn't, to A. See, a lot of students now, remember before we did addition, collecting like terms, it was fine. You said 3A plus 5A, you told me there were 8 A's. What if I changed it to now 3A times 5A? 15A. Yeah, and this is where, you see that confusion there. So I'll write it again, 3A times 5A. You break it up just like we did before, just on the previous slide. this would mean 3 times A times 5 times A. True? But we don't like the positioning because visually it looks confusing. So why don't you switch the A and the 5? This will now become 3 times 5 times A times A. You see what I'm doing there? 3 times 5 we know is 15. Well, what's another way of writing A times A?
A squared.
A squared, because you told me just now A times A times A was A cubed. So A times A has to be
B squared.
A squared. But what you can you see the confusion? It feels different or it feels harder. Just all I've done is I've just changed a letter. And that made a difference. When I gave you 3A times 5B, you're all switched on. You're like, oh yeah, 3 times 5, 15AB. No dramas. But as soon as I put that A in, changing that A, you just got to see it as A times the A. We know that we can rewrite this as not 2A, but it is
A squared.
A squared. And we know that this 3 times 5, 15. And 15 times A squared, another way of writing that? 15A squared. How do we feel? I know.
So if it was 3AB times 5AB,
Yes.
15AB squared.
Yes and no. So it depends on how you write that. That's a very good question, actually. Anyone know what it would be if I wrote 3AB times 5AB? What would the answer be? Yes. Now, Ina wasn't too wrong when she said, is the answer 15AB squared? Now, the way I've written it is wrong. The way I've wrote it, it says AB squared. See, because I'm putting the square on the B. But what if it wasn't the B? If I said it was like this, then Ina's correct. Because I'm now saying I've got AB times AB, it's AB squared. That would be correct. But what Aiden did was Aiden broke this up. Aiden broke the 3AB. What does 3AB mean again? Good. 3 times A times B. And this is still times. What's 5AB mean? 5 times A times B. Now, if we rearrange them, keep the numbers with the numbers. If I rearrange them, I can say it's 3 times 5 times A times A times B times B. Can you see what I've done? I still have 1A here, I still have 1A there, but I've just put them next to each other because it looks nicer. I've got a B and I've got a B, I just put them next to each other. 3 and the 5, Daniel. Thank you. 3 and the 5 are next to each other. Now you can see, you can break them apart. 3 times 5, which we know is 15. So I can group this and say this is 15. But then A times A squared. And then we've got another times here, B times B, B squared. So writing them all together, it has to be fantastic. Okay, now what I'm showing you right now is not going to be in your exercise book, but that's what you'll be doing year 8 and year 9. But you can see it's not that difficult. You don't have to move to year 8 to do what I just taught you, because the better you understand your foundation, I can give you anything, and you'll be able to do it. I could give you now, like, more crazy letters in there, and you should still be able to break it apart and rearrange it, okay? But in your textbook right now, when you're doing it, you're only going to see those kinds. These kinds, okay? And that's why I want you to get the understanding. And then yes, after that you can memorize the technique and say 3 times 5, A times A, and write your answers. But I need you to understand why it works.
If you had a question like X divided by 5.
Good. We're now doing multiplying, but I don't think I can finish. Oh, actually, we got 10 minutes. Maybe I can do that.
Yes, please.
All right, here we go. Now, forget about this example. Let's go to division. So multiplying, we understood. Break it apart, the letters. Now remember, A times A is A squared, but 2 times A is... What was that again? So I'll write it again. What's the difference between A squared and 2A?
2 plus A plus A.
Good. That's what I want you to keep in mind, yeah? Now it's the same thing with the division. Division, I'm going to just teach you one thing that you already know, but when it comes to letters, most students make this mistake. So, let's start off with this one. Yes, Daniel?
Do we have to do Ex chapter 5B, 5C, 5D, 5E?
No, 5B, C, D is what next Tuesday is. It's every 3 exercise, yeah? Now, let's go with this one. 3 over 3. What does this actually mean, Owen? 3 divided by 3. Now, what's 3 divided by 3? 1. So I know the answer to this one is 1. Okay, you sound like you're smart. What about this one now? 100 divided by 100, which is? Okay. So it seems like if I increase the numbers, you have no issues. What about this one?
1. 8.
Oh.
It's 8.
1.
Okay, answer still 1. You see, this is where the interesting thing, remember, A is a number. It doesn't matter unless it's 0, of course. It's a number. A is a number. I know it looks different. You see, when I gave you a number, you had no issues. I can change that number to a million, and you still say 1. But all I did was I put an A, and there was a difference. It's more of a visual thing. It's not the mathematics to it. It's the visual part. A divided by A is still going to be 1. Doesn't change. So that means...
Where does the 1 come from? It's just A, but A is still a whole number. So technically it could be A though, couldn't it? Yeah.
No. Because whatever A is, so let's say...
What if it's 5?
Okay. Let's say A was 5.
No, I get it.
Oh, yeah?
Yeah.
Yeah, that's what I'm trying to get at. If A was 5, it will be 5 divided by 5. If A was 7, it was 7 divided by 7. It'll always be 1. Okay?
What if you had to make x divided by 5?
X divided by 5. No, not yet. I'm going to get to that. Okay? Now, we're going to move on to this next example. So, you got your basics here. You got 3 divided by 3 is 1. 100 divided by 100 is 1. A divided by A is still 1. Now, let's try to work with this. Now I'm mixing the numbers and the letters. Now, I want you to use what you learned just on the last slide about multiplying. Let's break this apart. Let's break, yes, it is equal to half, but let's break this apart. What does 4A mean on the top?
A plus A.
Good. Or it means 4 groups of A, which is 4 times A. Over, what's 8A? 8 times A. Fantastic. Now, remember multiplying fractions? We did fractions in the last chapter. This is numerator by numerator, denominator by denominator. So that means you can split this fraction into 2. And you can see it as 4 over 8 times A divided by A. See what I'm doing? Now I know when you're doing it, you don't have to split it up. I'm just showing you why it works. 4 divided by 8, you're trying to find the highest common factor. You want to simplify 4 and 8. Oh, because what number goes in 4 and 8? 2 or 4. 4 is the highest common factor. So, how many 4s in 4? 1. How many 4s in 8? 2. So I know this is half, but we already know what A divided by A is.
1 less 0.
It's 1.
Ben already said that.
Okay. Okay, so this is why it works where you can say half times 1, the final answer is half. Now what you'll find in your textbooks, what they'll do, which I don't agree with, because this breaks it apart and you can see where it happens. Most teachers will teach it as just cross off the A's. If you have a top A and a bottom A, just cross them off. So hundreds, cross them off. 3, cross them off. A, cross them off. Problem with that is when I start using brackets and I put indices onto it, most students will just keep crossing. And that's the wrong part. I'll give you an example of what my year 12s normally do. So if I gave you x plus 1 plus 3 over 3 minus x plus 1. Okay?
I feel like your year 12 are pretty stupid.
No, it's all the basics. It's all the fractions. It's all the fractions. So we go. This is a common mistake that a lot of students do in the year 12 section when it's all about your algebra. The better your foundation, the better it is when you get up there. So when you're doing something like this and you're trying to simplify it, a lot of kids will do this. Because we would do A and A, they're like, oh yeah, you can cross them off. If you have a top and bottom, they're the same, cross it off. So here, you can cross out x plus 1 and you can cross out x plus 1. You can cross out the 3 and the 3. But why can't you do it here, but I could do it over there?
Because it's plus.
Exactly. There's only one key thing that was different about them, and we learnt fractions. Remember, I said the only reason why we can cross-simplify with fractions was only when you have multiplication. This is not multiplication. This is addition, subtraction. You now have one denominator. That's not a times. You can't just switch them like you could with 8a. See, I can do 8 times a or a times 8. You can switch them, but you can't do it here. And that's a common thing all throughout. You just can't cross-simplify these two terms. You can't even split those two fractions out. This one you could. This one you can split out.
So then how do you split it out?
No, you can't. You can only simplify the top. So it'll be x plus 4, and then this would be, well, negative x plus 2, but don't worry about that. Okay? All right, now let's go to May's question.
Yes.
Okay?
Yes. Finally.
May, I'm assuming your question is similar to this one. Is that
No, we
right?
just do my question please.
What was your question?
It was x
Yeah.
divided by 5.
Yeah, and this is like 3x plus 1 divided by 5. So when you say x divided by 5, the only thing you can write is?
1.
No.
5. 1/5.
Wait, what's another way of writing divide?
X
X over 5.
X. Yes, you can do that. X times 1/5, or the actual answer that I'm looking for, which is x divide means over.
Oh yeah, but this is how to get to it.
Yeah, and you're right. This is the intermediate step. When you say divide 5, you're really saying x times 1/5. That's what we learnt in.
1/5 x.
Yes, that's fine too. You can actually write your answer as 1/5 of x, because 1/5 of means times. All right. Now, this is the last example for today, and thank you. You guys have done really well. Okay, it's all about that practice. So we'll have tomorrow to practice this as well, and that's your time to practice and learn multiplying, collecting like terms, and dividing like terms. Okay. Let's try this one now. You've got 8ab over 12ab. Okay. Now, 12b. Whoops. 12b. Now, if we were to simplify this, what would you do? Do what I did in the last example. I splitted the numerator and I split the denominator. Now let's split the numerator. What would the numerator split into if I have 8ab? What does that mean?
You cross.
Wait.
No, you're right.
Do you mean like the 2 fractions?
Yep.
Don't you
So
cross
8
the b?
and then another fraction.
Good. This is 8, and this means times, because remember 8ab means 8 times a times b, so now I have 8 times a times b over there, yeah? Now, on the bottom I have 12b, this means?
12 times b.
12 times b, so I'm going to keep the number here 12, I'm still timesing, the denominator is b. See, I've just split it up. Now I've got 8 and 12, which is here, 8 and 12. This means times, I have times. That's 12 times b, I still have 12 times b. So they're still the same, but I split this up. Now, let's have a look at this. 8 over 12, we can simplify 8 over 12 to?
4.
Good, we can do it 4 over 6, so you can even simplify that even further.
3 over 2. 2 over 3.
2 over 3, okay, so we now know 2 over 3 times, now this is a bit weird, you got AB over B. We've got AB, I want to split this fraction even further. How do I split this up? Not b squared, that's only when you're timesing, remember? B times b will give you b squared. But right now, I've got AB divided by b. What I want you to see is in the top here, if I asked you, what does AB mean? What would you tell me? Okay, I'm going to write it out. A times the b. Now, b on the bottom, I only got b as a term. B times 1, very good, Daniel. I can write b as b times 1. Can you see what I'm doing now? I'm splitting it up now. Okay, later on you don't have to split this up. I'm splitting it up so you can see. Now if I split this fraction up, this is the same thing as writing 2 over 3 times a over 1 times b over b. Can you see what I've done? I've just split it up because that with 1a on the top, I still have 1a on the top. I have 1b on the top, I have 1b on the top. I have 1 on the bottom, I have 1 on the bottom, I have b, I have b. Yes?
Like there isn't b over b, a over 1 divide.
Wait.
Like that equals 1.
This equals 1. What's a divided by 1? A. Good. So if you simplify this, see, once you break it up, it's very simple. You can see it's 2 out of 3 times a times 1. So your final answer has to be 2/3 times a. We don't know what 2/3 times a is, so we just write it as 2/3 a. But times 1, it's just itself. So this is my final answer. Okay? Yeah? Now in your textbook, how they would like to teach it is they would say you can just cross off, if you've got a top and a bottom, you can cross off the b's, cross off the 8 and 12 to become 2/3, so you can write as 2a over 3. Right now. Yeah. Hey, Kai, come on, let's go.
Don't forget to like and subscribe.
Fantastic, thank you.
Bye, Michael. Bye, Michael.
Oh, this is for Michael, is it?
Yeah.
All right.